EFPTOZL.
Hey Beth, what are you up to?
I am testing my eyesight.
Why?
Well, the human eye is something that NASA keeps an eye on.
I see what you did there.
Ever since the early days, John Glenn was the first American astronaut to orbit the Earth. And in his capsule, he had these little tiny eye charts, and periodically he would have to test his eyesight. Now, what they're finding today is that astronauts, some of them who spend more than 6 months in space, some of their eyes actually change shape. So NASA's studying this to see if it's going to affect long-term spaceflight.
Wow, can I try the eye test?
Sure.
All right, here.
Try line 8.
THISIS stem in 30. That's, oh, this is stem in 30. I am ready to be an astronaut.
There's more to it than that. Have a seat. Sometimes, as an astronaut, you have to draw your own blood.
I'm not such a big fan of.
And do you want to be an astronaut? Marty? Marty? Okay, show me.
This is 7:30. Hi, I'm Marty.
And I'm Beth, and we are coming to you live today from the Moving Beyond Earth Gallery at the National Air and Space Museum in Washington, D.C.
We would like to welcome all of our online viewers and those watching on TV and remind you that you can submit questions today, and some of them we're actually going to use on the show. If you look on this side of the screen, you'll see a box where you can submit those questions, and we have additional content that we've added over there, including images and pictures that really supplement the show.
Now, we have a very large audience today. In fact, we have students from schools in Maryland, Virginia, and D.C. We are so glad you all are here. And Marty, if you look out at the audience, there is someone who's not like the others.
Yeah, there's one that doesn't quite look like they're a middle school student. What's going on there, Beth?
Well, today we have a very special guest. We have NASA astronaut Anna Fisher with us. Dr. Anna Fisher, thank you so much for being with us today. Are you ready to take some questions?
I'm ready, Beth.
Okay. Start.
Let's see. Alyssa, you have a question?
Yes. How did you feel when you left Earth's atmosphere and saw space for the first time through your own eyes?
Well, you know, that was a really amazing experience. First of all, launching on the shuttle and going from 0 miles per hour to 17,500 miles an hour in 8.5 minutes is quite a ride. So that was just really fun. But then once you get up on orbit and you look at this wonderful, beautiful planet of ours from space and you get to float, it was just the most amazing feeling you could ever imagine. Let's see, Caroline, you have a question?
Are your nutritional needs different in space?
You know, the nutritional needs in space really aren't that different from here on the ground. The food that we fly on board the shuttle and on board space station and pretty much any space vehicle is kind of like backpacking food, if any of you backpack or go camping. And it's really good. We have to be careful about salt intake on orbit so that it doesn't affect your metabolism. Mm-hmm. And then the other thing that happens when you're in space for a long time is that you kind of lose your taste for food, so people keep wanting it to be spicier. So, but in terms of nutritional needs and so forth, it's really not that different than here on the ground.
Okay.
Hey Maya, you have a question?
Yes. What have been the greatest scientific discoveries that have been found by experimenting in space?
Well, we found a lot of things since the very beginning of the space program. Many things that we now take for granted. The miniaturization of computers, having telemetry, like from the paramedics when paramedics are picking up people out in the field, and then on board space station we do hundreds and hundreds of experiments. We're learning how to grow proteins in space. We're learning how flames propagate in space. We're studying how fish and ants and different insects and animals, how they adapt in space. And so we're just doing many, many things. And one of the neat things about science is you never know what you're going to find out. You may start out thinking one thing and find out something different, but it's always fun to use your math and science to make new discoveries.
Well, that's just the beginning. We are going to have a lot more questions as we go along today, and Anna will be here to answer them. Now, we will be talking about science in space, but Marty, you learned that science in space actually starts here on Earth.
It does. The other day, Beth said, you need to go to this greenhouse, and I wasn't real wild about that idea, but it grew on me, so let us head over to the greenhouse. I'm at the Smithsonian Gardens greenhouses, and I'm going inside to talk to Brett McNish, a horticulturalist. Come along with me. You guys are going to dig this. Hey, Brett, how's it going?
Hey, Marty. Welcome to the Smithsonian Gardens greenhouse facility in Suitland, Maryland.
This place is incredible, and you've got some awesome plants here, but this one's kind of funny looking.
Yeah, you notice this. Let me talk to you a little bit about it. This plant here is amaranth. Amaranth is a very common annual that we grow during the summer out in our display gardens. This one's a little different. We decided to have a little bit of fun to show folks an example of geotropism.
Okay, so what is that?
So geotropism, or gravitropism, is the plant's response to gravity. Now we know plants want to grow up toward the sun to get that sunlight, and they also want to send their roots down into the soil where there's nutrients and water. Now, down here we have an experiment where we've taken a plant and we've grown it upside down. And now this plant is trying to grow up toward the sun. And it's done a nice curve here. It looks just like a soup ladle.
And growing plants in space, this shows that it's not real easy.
Right. In space, you have a low gravity or zero gravity environment. Plants going to get confused. In fact, they've run experiments like this in space, and they've seen that the roots and shoots will grow in the same direction, crazy directions. So very confused.
And there's been an experiment recently on the International Space Station called Veggie.
Yes.
What do you know about Veggie?
Veggie, I think you're talking about growing salad greens in space. Outrageous was the name that they enjoyed up there. Well, we know that plants require some things to grow. So they need nutrients that they'll get through soil or growing medium. They need water, they need CO2, and they need sunlight. So they're going to have to replicate all those things in order to grow that salad in space.
Kind of like a greenhouse.
Exactly, a controlled environment.
I actually got a chance to talk to astronaut Kjell Lindgren, who was on the International Space Station when they harvested that first crop of lettuce. And he had some thoughts about the importance of growing plants in space beyond just getting a chance to eat them. Check this out.
One additional benefit that I think was very powerful was a psychological aspect. You know, we garden here on the Earth because it's fun, and I think it's the same on station as well, to be taking care of this living, growing thing on a daily basis, to watch it grow, and to see this green living thing in an otherwise white and stainless steel sterile environment of the space station, I think was very psychologically helpful.
Anna, you have a great story about that experiment. Why don't you tell us a little bit about it?
Yes, one of my colleagues, Kimya, was on that same expedition that was growing the lettuce in space, and he told us a story about how his father, he's from Japan, and he was a first-generation son, wanted his son to continue in the tradition and be a farmer as well. But Kimya had other ideas. He wanted to go be a pilot and eventually became an astronaut. So when he was on board the space station and grew that lettuce and ate it, when he got back to Earth, his dad asked him which lettuce was better, the lettuce that we grow on our farm or the lettuce that you had in space. And of course, being the diplomatic person he was, he said that it was his dad's.
Yeah, but he did get to farm, just not here on the Earth.
they each got to pursue their dreams, and yet eventually he fulfilled his father's dream of following in his footsteps, sort of.
Now, you were of the first class of astronauts that included women, and you were also the first mother who went into space. Do you want to tell us a little bit about those experiences?
Well, it was just as much, I felt so honored to be in that first group of women that was selected in 1978. And it was a time that NASA was just prepared and ready and welcoming women. It was a wonderful experience. And then also getting a chance to be the first mom to go into space. My daughter tells me I owe it all to her. But it was a very challenging time, but at the same time, both of them were equally important to me. So it was really special. But juggling the two of them was quite the challenge.
I imagine it was, because there's a lot of training that goes into being an astronaut.
A lot of training, and also, being a first-time mom, you're learning all of that too as well. So it was pretty challenging, but probably one of the best years of my life.
Shall we take some questions?
Sounds great.
Okay, let's start with a video question.
Hello, my name is Madison. I'm from South Valley Middle School, and I was wondering if there's any disadvantages to being a woman in space.
There's really no disadvantage that I can think of, other than some of us that are on the smaller side, we didn't fit into the spacesuit, so we weren't able to do spacewalks, but we're working real hard to design a suit in the future that'll fit pretty much the entire range. We have perhaps one very slight advantage in that we've had some astronauts come back with changes to their vision. A lot of theories as to why that happens, but so far, and of course it's not statistically significant, none of the women have had that problem, so maybe there's a slight advantage, but realistically, males and females all do the same job, we do the same training, and there's really not an advantage or disadvantage either way.
Okay, we have an online question. How do you conduct science on the International Space Station with the limited working space?
Well, it's really not that limited. I mean, the size of the space station is quite big, actually. It's about the size of a 5-bedroom house here. And the actual laboratory portion of it would be like 3 of the bedrooms, kind of the European module, Japanese module, and then the US laboratory. And also in weightlessness, the thing that's unique, in addition to it being zero gravity, is the fact that you can really use that entire volume. Whereas here you're limited to being able to put things on the ground. You can use that full dimension. So it really winds up working out just fine.
Okay, and Marty has an audience question for us.
How do you stay in shape in space?
That's a very good question, because it's very important, particularly on these long missions, to try to stay in shape and to make sure that you don't have bone loss and muscle loss. So we have several exercise devices on board. We have a rowing machine, we have a bicycle that's in the Russian segment, and then we also have a treadmill and a resistive exercise device. And every astronaut is scheduled for 2.5 hours of exercise. Every day they do an hour of aerobics and an hour of resistive training. And people are starting to come back in sometimes better shape from a 6-month mission than they did from some of the shuttle missions where we didn't really have that type of equipment on board.
Sure.
Good question.
We have another video question.
Hi, my name is Donovan. My question is, how's the view from space?
The view from space is as spectacular as you could possibly imagine. One of the things we did on our flight is, after we said goodnight to mission control, we would take an hour into our sleep period and just go sit up by a window and look out the window and watch that incredible view. One of my favorite views was looking at the snow-capped Himalayas with a full moon. It's just absolutely amazing. And then you realize as you look out into the vast darkness of space that we are all on this beautiful, wonderful planet with just a very thin sliver of atmosphere, and really need to take care of this planet. But it was just absolutely amazingly beautiful.
Marty has an audience question.
How does being back on Earth feel after a space mission? Does the human body react in a different way after being in weightlessness for a while?
You know, it takes a little while to adjust to going into space, and then when you come back, it takes probably about a day or two for a shorter mission, and then quite a bit longer for these 6-month missions. I remember when we landed, I felt like an 800-pound gorilla. I mean, it's just all of a sudden, and I was only in space for 8 days, so, and I had some switches that I had to throw on the overhead panels, and in the simulator, I did it in 15, 20 seconds. It probably took me several minutes to lift my arm up and make sure that I got the right switch. But very quickly, within a day or so, you adapt. But I do remember going to bed that night when I got back, and I kept feeling like my feet were floating away, and I'd always have to open my eyes to reassure myself that no, I was really back in gravity. And then you quickly adapt going back. But for about a day or so, you're just a little bit wobbly and uncertain.
We've talked to a lot of different astronauts about their experiences of doing science in space, and one of them was Stephanie Wilson.
I'm joined by astronaut Stephanie Wilson, a veteran of 3 space shuttle flights. You spent 42 days in space.
Yes.
Thank you so much for joining us.
Thank you.
So tell me a little bit about the science that goes on in space.
We have several areas that we're conducting science research on the International Space Station. Some of the areas include Earth observations, physical science, human physiology and biology. And so in some of those areas for the Earth science, we are of course looking back at Earth to see changes in Earth, deforestation, how we can better predict storms and weather patterns. For the physical sciences, we have many materials that are being exposed to the vacuum of space, so we can learn more about improvements in materials. We also have a combustion facility, so we're learning about burning materials and fire suppression on board the International Space Station. So much work is going on in the area of science on the space station.
Now, as a mission specialist, one of the things that you had to do was control the robotic arm to retrieve a satellite. And that's not as easy as it sounds, is it?
No, it's definitely not as easy as it sounds. It took quite a bit of training and a lot of planning and thinking ahead of time as how we were going to do that, because that satellite is about the size of a school bus here on the ground.
And you were successful in that, and everybody got the satellite back, and
we brought it back, and 2 of them, as a matter of fact, and we were able to relaunch them about 3 years later. The Chinese government launched them. So,
okay.
Cool.
And one of the things that satellites have to have to stay on track or in the right orbit are gyroscopes. And Marty, do you want to tell us a little bit about what you're doing here?
Yeah, so I've got Tyrus here, and he has a bicycle wheel that he's holding with a couple of handles on it, and he's standing on a platform that moves real easily with no motors in it or anything like that. There just has to be a force applied to it. And so we're going to look at Newton's third law today. Now, we all know that Newton's third law is that for every action there is an equal and opposite reaction. I love that. Nice job, guys. So we're going to kind of put that into place while we're also looking at gyroscopes today. So I'm going to have you hold this out here, and I'm going to spin this wheel fast. Okay, so hang on. All right, now tilt it to the left. Now tilt it back to the right. Oh, now tilt it back the other way. All right, so what's happening here is that we've applied a force in one direction, and when he tilts when he tilts the wheel, the opposite reaction pushes him back the other way. Now, Tyus, how did you feel while that was happening?
I was getting like pushed or forced to the side that I was twisting it to.
Did it feel a little weird? All right, so this is a great example of Newton's third law in action, as well as a gyroscope. And we know that gyroscopes are incredibly important for guidance systems on satellites.
And when those guidance systems don't work, we have astronauts to go out and retrieve them.
Exactly.
Now, you studied to become a medical doctor. Mm-hmm. How did that experience help you for your career as an astronaut?
Well, one of the things that, just really any scientific discipline helps you to become an astronaut. But particularly with medicine, I was able to help on board my flight as the crew medical officer and help developing some of the equipment for the space station. But I think the number one way it really helped me was learning to live without a lot of sleep. And so when I came to NASA and I saw that on the flight plan you actually had 8 hours of sleep, they actually thought you needed sleep to do a good job. That was just very welcome.
Now, we've been studying astronauts since the beginning of the program, and we actually got a chance to talk to Apollo 11 astronaut Michael Collins about his experiences.
I am joined by Michael Collins, who flew on Gemini 10 and Apollo 11. Thank you so much for talking with us today.
Thank you. Delighted to be here.
Now, you were part of the space program when really it was in its infancy, and there were a lot of experiments going on. Did you ever feel like a guinea pig as you were flying around?
Oh, frequently, yes. Because of course, guinea pigs are always getting injected and subjecting themselves to the latest medical advances, and we had a fairly strong, but fortunately a very friendly and competent medical component to our training.
What did we learn from that that helps us now with long-term space flight?
Well, there are a number of things, many of which I have just read about. For instance, effects on the blood supply to your eye, which changes in weightlessness. Of course, we felt stretched out. We actually were a little bit taller because the space between your vertebrae extends a bit. These things are not important at all for the kind of work we were doing, to the moon and back in 8 days. Not a medical challenge in that, but if you're talking about several years to Mars and back, then the medical component, the medical considerations become extremely important, perhaps paramount to such a trip.
One of the nice things about having astronauts on is that you get to have a conversation with them prior to the show. And you have a really great story about your necklace. Do you want to tell us a little bit about that?
Yeah, my husband had this made for me before my flight, and it has a star in Houston and a star in orbit, and also had two made for my two daughters that I eventually had. So it was just really fun to wear this, and if you look at the videos of our flight, you can see the necklace floating around.
Do you guys get to take up a lot of personal stuff?
Well, we don't get to take a lot. I think for the shuttle program, I was trying to remember, I think you got to take 10 or 20 items, and they had to be relatively small kind of things. And so you got to have a few personal things, which was really fun. But the other thing that you got to do, which I really enjoyed, was we got to fly things like for your alma mater. Like I went to UCLA, so I flew a little banner, UCLA banner, and for my medical school, which was also UCLA, I flew a really old book from the 1800s with the Hippocratic Oath in it. So it's a way of giving back and sharing the experience with people who helped you along that pathway.
And you still work for NASA. Do you want to tell us a little bit about what you're working on now?
Well, yes, I'm still at NASA. I think I'm probably the longest serving active astronaut. And I work right now on Orion. I'm working on the displays and procedure viewer. We're going to try to go to pretty much entirely electronic procedures and control of the vehicle. So that's what I'm working on at the moment. But it's really fun.
And does NASA still keep up with your health after being an astronaut?
Oh, for the rest of our lives, if you choose to participate, which I think a large number do, you can come back to NASA for annual physical, because they're looking at longitudinally all the astronauts from back in the Mercury days all the way to now, and with various different lengths of time on orbit, to see if there's any impact from weightlessness, from radiation, and anything we can learn to help future exploration, like going to Mars and stuff. Mm-hmm.
More questions?
Always happy to answer questions.
Let's start with a video question.
Hi, my name is Bryce, and I'm from South Valley, and I was wondering, how long did it take for you to get used to zero gravity?
Getting used to zero gravity is a pretty quick process. Most, or a large percentage of astronauts have space adaptation syndrome, which is very similar to seasickness. It usually takes anywhere from 1 to 3 days to get over that. The symptoms are very much like being seasickness, although it's probably due to the fluid shifts and the conflict of what your eye is seeing versus what your inner ear is detecting. And once you get used to that, then you're like a baby learning to walk. You're a little bit more clumsy in weightlessness. If you watch some of the astronauts who've been on board space station for 6 months, they get to be really very cool. They can just very slight movements and get themselves oriented. When you first come on board, you're not that skillful at weightlessness. But you adapt relatively rapidly. In fact, I was surprised how quickly you can adapt to such a very strange environment.
Let's take an online question. What was the most challenging task you had to do before becoming an astronaut?
I think the most challenging thing for me was the fact that I didn't know I was going to get to be an astronaut. You know, I had felt that it had already passed me by, even though I'd had that dream since I was 12 years old. And so it just came about unexpectedly. And I'm one of these people who is kind of concerned when something so major happens serendipitously. But I think probably the hardest thing about becoming an astronaut, the most challenging, is just everything that you have to do. I mean, you either have to become a pilot and go to the military and get thousands of hours, and then go to test pilot school, which is quite challenging from listening to my colleagues. And then the other, if you choose to be a mission specialist, whatever area you decide, whether it's a doctor or a PhD, there's a lot of work that goes into either one of those. So that's, and then all the other things that NASA looks for, like whether you're a private pilot or a scuba diver or mountain climbing and all those, just getting all of that together.
Marty, do you have an audience question for us?
Can you experiment with spiders in space?
Marty does not like spiders.
I'm not a big fan either. But I don't know that we've had spiders in space. I know we've had fish. I know we've had ants. We've probably had spiders. Yes, we probably do. But there is nothing that you can take up in space with you that isn't approved and go through this huge approval process. So you can't just like slip a spider into a Ziploc bag and take it with you or something just so that you can do your own little experiment. That has to all be very well thought out. They have to decide if it's safe and whether it's a danger to yourself and to others. And so it goes through this long review process. Otherwise, I would have loved to take tons of different things with me into space and have fun with it.
I think we have another video question.
Hello, my name is Hannah and I'm from South Valley, and my question is, what inspired you to become an astronaut?
Okay. What inspired me to be an astronaut was when I was about the age of most of you in this audience. I listened to Alan Shepard's Suborbital Flight early one morning, and I listened to that, and I just knew at that moment that's what I wanted to do. And I never forgot that, and I never lost sight of that dream, even though it didn't seem like it was possible. And so that's one thing I would say, just, you know, if you have a dream, go after it.
Now, we talked to one last astronaut about his experiences on the International Space Station.
I'm joined by Tim Coper. You spent 244 days in space. Thank you so much for talking with us today.
It's my pleasure.
When you were in space, there were a lot of experiments going on the International Space Station.
Yeah.
Why is that important?
The space station is a world-class orbiting laboratory right now, and we're doing a vast array of different experiments. Some of it's basic science. A lot of it pertains to learning what happens to the human body in zero gravity. If we want to get beyond low Earth orbit, we need to really understand these different effects, a lot of which are negative. We lose bone density, muscle mass, and there's problems with eyes. So we're learning a lot about that, and that's what we did on board the space station with our investigations.
Now, were you the guinea pig while you were up?
You know, we're like scientists on board, so we're either the technician or maybe we just monitor the experiment. Oftentimes we are the experiment, and so we're taking samples, we're looking at our eyes, we have world-class equipment. It looks like an optometry clinic, really, and so we're trying to understand all these different effects.
And all of those things that you're studying are going towards a future trip to Mars.
We definitely hope to go to Mars, and it's going to be really, really challenging. The whole human aspect, we can get probes to Mars, but to get humans to Mars is going to be a big challenge, and we need to understand these effects.
Awesome. Well, thank you so much for joining us today.
Well, that's all the time we have. Anna, thank you so much for joining us. We also want to thank our sponsor, NASA. Next month, we will be looking at the Wright brothers. Check this out.
Check this out. This is a Wright bat, a toy very similar to what the Wright brothers' father gave them that sparked their interest in aviation, that led them to invent this, the Wright Flyer. But it wasn't just that spark that led them to invent the airplane. It was also a lot of design and a lot of math. They did a lot of aerodynamic testing and refinement of the wind tunnel that led them to this invention, the first in flight. If you want to learn how the Wright brothers invented the airplane, be sure to check out
7:30.
Thanks for joining us. We are going to be around for a couple more minutes if you want to join us after the program. Anna will be here to answer questions. But let's watch your Space Shuttle Discovery launch.
Sounds like fun.